Today on Engineering Newswire, brought to you by Mouser Electronics, the electronic components distributor with the widest selection of the newest products. We're giving amphibious airplanes a new angle of attack, flying self-assembling supercopters, building rocket engines that breathe, and planning the Hyperloop. From now on, we'll travel in tubes.
Jaws dropped when quadcopters were programmed to fly in coordinated patterns in tight spaces. Don't ask me why, but it was even more impressive when they made the things backflip. Now researchers at the ETH Zurich have managed to make the vehicles not only fly in synchronization, but self-assemble into a supercopter. My word, not theirs. The researchers have called the mass of individual vehicles a distributed flight array. Supercopter was better, but what do I know? The individual vehicles have fixed propellers that can lift them into the air, but due to the nature of using a single propeller this way, their flight is erratic and difficult to control. If the vehicles are not in an array, they will quickly tumble to the ground due to the unchecked torque from one propeller. Each vehicle has 3 omnidirectional wheels, which they use to find each other on the ground. Once in a common area, the vehicles exchange information and combine the data with individual sensor measurements to determine the proper thrust for the Chimera to lift off. The task of keeping the array in level flight is distributed across the network of vehicles. If a level flight is disturbed, each vehicle compensates appropriately to keep the array airborne. Reminds me of another self-assembling robot.
Form feet and legs. Form arms and body. And I'll form the head.
The first plane to debut from consumer sport plane manufacturer Icon Aircraft, the A5 is an amphibious sport aircraft that can take off by land and by sea. This week, Icon released details of the new angle of attack system, a safety feature rarely found in general aviation aircraft. The A5's AOA gauge is an intuitive, real-time graphical indication of the plane's stall margin based on wing performance. Traditionally, pilots evaluate an airplane's proximity to stalling by observing the airspeed indicator. However, stall speed varies in relation to the wing loading, something that an airspeed indicator does not account for. Pilots flying by airspeed are forced to compensate for factors such as weight, G-load, center of gravity, and wind gusts. With the AOA, pilots have a single, easily understood metric that provides instantaneous information about how much lift the wing can deliver before it stalls. They are common in military fighter aircraft, but cost and complexity have historically prevented widespread implementation. In the A5, it's just another feature in an aircraft already in high demand. With a price tag of $140,000, the craft has more than 940 order deposits and has already begun manufacturing components of the first production aircraft.
The British government is investing $92 million on an air-breathing rocket engine for a single-stage to orbit spaceplane, which will eventually be lighter, reusable, and able to fly from conventional runways. This unique synergistic air-breathing rocket engine, or SABRE, designed by Reaction Engines, will use atmospheric air in the early part of the flight before switching to rocket mode for the final ascent to orbit, paving the way for true space planes. Reaction Engines plans for SABRE to power a 276-foot-long pilotless vehicle called Skylon, which would do the same job as today's rockets while operating like an airplane, revolutionizing access to space. The investment decision followed by the success of ESA managed test of a key element of the SABRE design, a pre-cooler to chill the hot air entering the engine at hypersonic speed. According to Mark Ford, head of ESA's propulsion section, the idea of an air-breathing engine has been around since the 1950s, but this is the first time anyone has managed to achieve a working system. Nobody else has this technology, so Europe has a real technological lead here. Too bad everyone is still talking about that baby.
Wheels and kite. Planes, trains, automobiles, and Hyperloops. Elon Musk, the creator of PayPal, CEO of Tesla Motors, and the man behind SpaceX, has done it again. We previously mentioned Elon's up-and-coming Hyperloop transport system, but now the entrepreneur has one-upped himself. On July 13th, Musk turned to Twitter to announce that he will publish his Hyperloop design by August 12th. Musk is even seeking feedback from his Twitter base regarding possible improvements or suggested design adjustments. Engineers, that means you. It was even more profound when Musk announced that his revolutionary pneumatic tube transport system was going to be open sourced. Again, we go to the tweet. I really hate patents unless critical to company survival. We'll publish Hyperloop as open source. His design is basically a massive vacuum tube that would be combined with a magnetic levitation system, similar to high-speed bullet trains. The design aims to be extremely fast and efficient while remaining safe and comfortable. One thing I know for sure, I can't wait till August 12th. Get the scientists working on tube technology!
Do you have story ideas? Comment below and we'll cover them in the next episode. For PDND TV, I'm Annabelle Zimba, and this has been your Engineering Newswire.
Where are you?